All right, class, welcome. Today, we're going to dive deep into a really critical part of corporate finance and strategic planning, and that's the mathematics of future value. Now, I want you to know this isn't just about crunching numbers, it's about developing foresight. We're going to explore how companies take these huge, ambitious goals, like a massive expansion or paying off a big debt, and turn them into a disciplined, step-by-step savings plan. The main tool we're going to master today is the annuity calculation, and I'm telling you, it's an absolutely fundamental skill for any of you who want to be financial leaders. So let's start with a scenario that I can pretty much guarantee you will face at some point in your careers. I want you to imagine you're the CFO, the Chief Financial Officer. The board just gave the green light for a major capital expansion. It's 10 years out, and you're responsible for the financial roadmap. The price tag? A cool $1 million. Now, this isn't just some number on a spreadsheet, right? This is a strategic must-win for the company's growth. So the big question for you, as the person in charge of the money, is this. How do you systematically, methodically build the capital to make sure that money is sitting there ready to go precisely when you need it? That's the problem we're going to solve together today. So here's our game plan for today's lecture. First, we are going to meticulously pull apart the annuity formula, making sure we understand what every single piece does. Then, we'll shift from theory to practice, and we'll apply that formula directly to our million-dollar case study. After that, and this is crucial, we're going to talk about how to avoid common mistakes, the little errors that can have huge financial consequences in the real world. And finally, we'll zoom out and talk about the big picture, connecting this mathematical tool to your future role as a key decision maker in a business. All right, let's get our hands dirty and look at the mechanics. To solve our problem, we need a very specific financial tool. And I want you to think of this formula we're about to see as the engine that's going to power our entire saving strategy. Just like an engineer has to understand every single gear and piston before they turn the key, we have to understand the individual parts of this formula before we can really use it effectively. The official term for what we're building here is a sinking fund. And it's a really fitting name. The whole idea is to create this dedicated savings account to prevent the company from being sunk by some massive future bill. This could be anything: paying back a corporate bond, building a new factory, buying a huge piece of equipment. It's really a fundamental tool of smart financial management. It's about replacing a future moment of panic with a disciplined, predictable, periodic contribution. And our job today is to figure out the exact size of that periodic payment. And here it is. This is the engine itself. Now, I know, at first glance, this can look a little intimidating, but I promise you, the logic behind it is actually very elegant and surprisingly straightforward. At its heart, all this equation does is define the relationship between a future goal and the regular payments you need to make to hit that goal. And the secret ingredient, the thing that really supercharges the whole process, is the power of compound interest, the effect of your investment earnings generating their own earnings over time. So let's break it down piece by piece. Okay, so every part of this formula is a critical piece of our financial puzzle. First up is R, that's for the regular payment. This is the mystery we're trying to solve. It's the exact amount of cash the company has to put away each period. Next, S sub N, that's the future value, that's our destination, our clear target, the $1 million. Then we have I, the interest rate per period. Think of this as the wind on our sails. It's the rate our money will grow all by itself through investments. This is a really important assumption we have to make. And finally, N is the number of periods. That's our timeline, the total number of payments we're going to make. Truly mastering this formula means understanding how these four pieces all dance together.
All right, enough theory. We've examined the formula, but, true understanding really comes from actually using it. So let's move from the abstract world of variables to the concrete world of our case study. We're going to take our formula and apply it directly to that challenge we started with, getting to $1 million for our company's expansion. This is where the numbers really start to tell a story.
First, we have to clearly define our objective, our North Star. The future value, or SN, that we need to hit is exactly $1 million. This is our target. It's the number that's going to drive every single part of our calculation. It's tangible, it's clear, and it's non-negotiable. Okay, now let's get organized. Let's take the data from our scenario and map it directly to our variables. So our future value, S sub N, is $1 million. Easy enough. The number of periods, N, is 10 because we're planning for 10 years and we're making annual payments. The annual interest rate, I, is 6%. And this is critical. For the formula to work, we absolutely must express that as a decimal, 0.06. So, with those three knowns locked in, the only thing left to figure out is R, that required annual payment. Now, we just substitute these values right into our formula. So R equals $1 million divided by that whole big expression on the bottom. Now, I really want you to focus on that denominator for a second. That complicated-looking fraction actually has a name. It's called the future value interest factor for an annuity, or FVIFA for short. And what it calculates is really cool. It tells you the future value of a series of $1 payments. In our case, it tells us exactly what $1 invested every year for 10 years at 6% would grow to. So by dividing our $1 million goal by this factor, we're basically just asking how many of those $1 growth streams do we need to build.
And after we run the numbers, we get our answer. The required annual contribution to the sinking fund is $75,867.98. Now, let's just pause here and really appreciate what this number represents. We've just taken this huge, daunting, long-term goal, and we've transformed it into a clear, manageable, actionable annual task. We can now walk into that boardroom with a definitive plan and say, to hit our $1 million target in 10 years, assuming a 6% return, we need to set aside precisely this amount every year. That is the power of financial mathematics. It gives you clarity and precision.
Now, listen, knowing the formula, that's one thing. Executing it perfectly, under pressure, is something else entirely. As a professor, this is where I see students, and frankly, even professionals, make some critical mistakes that can have really serious financial consequences. So let's make sure that you don't fall into these common traps. Okay, I need you to pay very close attention here because these are by far the most common errors I see. The first one is a mismatch of periods. The formula demands consistency. In our example, we used an annual interest rate and an annual number of periods. But what if the company decided to make monthly payments? Well, then we would have to adjust both I and N. N would become 10 years times 12 months, so 120 periods. And I would become the monthly interest rate. You take the 6% annual rate and divide it by 12, which gives you 0.5% per month, or 0.005. If you use an annual I with a monthly N, your result will be wildly wrong. The second error is simpler, but just as bad, forgetting to convert the percentage to a decimal. The math just doesn't work otherwise. Plugging in the number 6 instead of 0.06 will give you a catastrophically wrong answer. These aren't small details. They are the absolute bedrock of financial accuracy. So let's zoom out. We've mastered a calculation, but what we've really learned is a principle of strategic management. As a business leader, your role isn't just to be a human calculator. It's to use the math to make smart decisions and to guide your entire organization towards its long-term goals. So why is this specific calculation so incredibly important in the business world? Well, because the logic behind it applies to so much more than just this one project. This exact same method is used to fund corporate pension plans, to make sure the money is there to pay off a bond, or to plan for pretty much any big future expense. What this process really shows is how a good manager can take a vague, intimidating goal, we need $1 million, and systematically break it down into a disciplined, manageable, and totally actionable financial plan. I want you to remember this quote. The calculations that we do, they're not just lifeless figures on a page. They are the grammar and the vocabulary of the story of your business. They tell a story about growth, about stability, about foresight. And your job as a future leader is to understand that language and then use it to write the next successful chapter for your company. And we'll end on that thought. You now have a powerful analytical tool in your toolkit, a framework for turning a strategic vision into a financial reality. So the final question isn't for me to answer, it's for you to think about as you move forward in your careers. You have the formula. What future will you build with it?